Alright, in today's video we'll be showing the use of the AOI we made. So just to quickly kind of go over it, we made a dry or conveyor control AOI. We had our parameter files, our parameter tags we put in here, inputs and outputs, our local tags that will be used during the internals of the instruction. But everything on the parameters will be actually inputs and outputs that you have to use on the instruction itself. So that's why they're made visible on the column over here. I did have a video that showed how I made that. I will put that in the show notes below, but it was the video prior to this one. So real quick, what we're going to do is we're going to add a couple I/O modules. This is using the 5000 emulate chassis. So this is a RSLogix emulate 5000 chassis, and I will not be using any kind of I/O like real world I/O, although I will be adding it just to show a simulation. So real quick, we'll go ahead and do that in the back plane, and we'll come in and just basically add in some just an input and output module. So we'll do just a regular 24 volt DC input, and we'll just call it input. We'll put it in slot 2, and then we'll add another one for the output. So we'll come in digital, and we'll put one for the output as well. So that's AC. We can use AC, it don't matter. So we'll put AC output, and then we'll put that as slot 3. And again, so what we're not going to actually have these modules because we're emulating. So in the connections, we want to inhibit those so that we can run the emulator and it not be affected. So we won't have a blinking light. We won't have any kind of issues or anything like that. So just we'll emulate those real quick. Now, as far as using the instruction, so what we'll first do is we'll show the instruction being used in a standard routine ladder logic. Come in here, we'll add a rung, and then we'll come in here and add the instruction. So if you look at, normally it starts off in favorites and has add-ons, alarms, as far as you're up here in your editing. We have our add-on instruction that we made up here in the add-on section. Simply drag that down, and this is where we're going to fill in our data. So what I'm going to do, just to kind of give a visual of this stuff working, I'm going to put 2 rungs, and one above it, one below it, and they're going to be no operation rungs, so they're just going to show you. There's just a way for me to easily toggle these bits. So what we'll do is we'll call this, now you have to name the instruction, right? So say you want to use this instruction for multiple conveyors. In this instance, we're going to have conveyor 1, and then we're going to just create that. And then for the start push button, we'll have conveyor 1 start. And then what we're going to have to do is alias this type. So we're going to make the type an alias. We're going to come down to your alias, and we're going to have our inputs. And then we're going to go to, we'll use basically input 1. Input 0 I'm going to use for my e-stop. So just kind of get a clarity on that. And then we'll go ahead and make this the conveyor 1 stop. And then again, we're going to change the type to alias. We're going to alias it for the data type of 2, so the second input. So now we're going to go to and add the e-stop. So conveyor, and this can be the general. So conveyor system e-stop, because it's going to, you can use it for multiple things, right? So we're going to alias it. We're going to bring it down to the data type. We're going to use that as 0 on the second card. Now, the conveyor run, what we want to do is we want to put conveyor 1 run command, and we'll put that as run command. We have to alias that. We'll alias that to an output, the output that the module that we put down below, and we'll put that as output 0. So real quick, we made the tag, we put the start button, stop button, put the e-stop button, and then the run. So what we'll do, just to kind of highlight that, is I'll come in here and put the buttons up top, and I'll just drag these over here so you can see me toggle them, and you'll see the instruction work. And then we'll go back through the logic as well too, and then we'll come back and add one on the bottom. So as far as that works, and this would basically be the representation of the standard ladder logic. So what we'll do, we'll go in and we'll download this real quick and watch it run. Okay, click it in run mode, and if you look at our logic, what we can do is we can go to right click. If you right click the add-on instruction logic or add-on instruction, you can open up the logic itself, and you can look and see where the current state of that is. So if you go up here, you can look at the true definition, and if you go, you can see how many instances you have. So if you have multiple conveyors or multiple instances of using this instruction, they will all be in this populated. So at this point we got our e-stop, but we got to push on. Then it's going to cut on, and then we'll put our start button after that. After 2 seconds, then it will basically start the conveyor. So what we'll do is we'll toggle this bit, and then we'll come in, and if you look, we should have the 2-second timer timed out, so it's okay. So it's waiting on the start button at this point. So if we hit start, the output comes on. So this, now granted, rung 0 and 2 do not need to be here in standard function. If you were programming this, you would just need to have multiple instances of the actual instruction. So if we wanted to actually have another one, we just come in here and do the same thing. We can say conveyor 2, and make that one. So conveyor 2 start, and then alias that to whatever input you wanted to have it at. In our case, we'll just throw in a simple input, the next one in line, right? So 3, we'll do the stop. So conveyor 2 stop. We'll do the alias again, and we'll come into and throw in the next one in line. And in general purposes, this is just going to work for what we're doing. The conveyor system stop, e-stop, we can push. That's going to be a generic one. It's going to be for the whole system. So at this point, we'll put conveyor to run command, right? And then we want to put the next aliased output that we currently have. So we'll put, I believe this is going to be 1. Yeah. So in the instance of what we have here, if we toggle this bit, so if we toggle the start bit, if we looked at this one right now, the only thing it's waiting on is the start, because the e-stop is not pressed, right? So if we come in here and if we toggle the e-stop off, then you could currently see that we don't have a okay to run the conveyor on either one of these, because the general scenario, the global issue right now is the e-stop is pressed, right? So if the e-stop is good, we're going to come back and look at the instruction logic again, and it's ready to run except for it's waiting on a start button. This should be on both, right? And actually the start button was pressed on this one, so it started back after 2 seconds. So now what we'll do is we'll come in and we'll highlight, we'll come into the start button and we'll press the start button, and you see the run command came on. So if you want, you don't have to have these on or off. I'm just basically showing it for simulation purposes and showing it to give you an illustration of what's being pressed and all that. So as far as that goes, that gives you a good indication of what's going on. So if you stop it, you can plainly see that what's going on. So real quick, so now we have function block, right? So let's take it offline again real quick, and let's open up the function block. I want to change the properties of this to a bigger sheet layout. Let's go with like a 17 by 22, just to kind of give it more room. And what we'll do is we'll add in the add-on instruction into this. So we'll call this, we'll edit that and call it conveyor 3. So for conveyor 3, we want to put in a start, a stop, and then again that global e-stop. So for the global e-stop, we'll just come over here and click edit, copy it, go back over here and click paste. And then we'll simply just tie that in right there. Now for the start, we'll do the same thing we did. We're going to have to make the tag, right? So conveyor 3, and we'll put start. And we'll make this an alias, and we'll throw in the next one down in line. So the next input that we have, just for simulation purposes, is a 5. And we'll throw that as the start. And I kind of like to keep it as clean as possible. So what we'll do is we'll come in and make the next one as a conveyor 3 stop. And then we'll come in and make this the next alias down, which would be the input 6. And now we need to do an output. So we need to cut the output on as well. So this would be the conveyor 3 run command, right? So at that point we want to have this as an alias, a dent, and not a dent, but alias, and it's going to be this next one in line is the slot 3 data 2. So slot 3 input or output 2, and we'll just simply tie that in just like this. Right, let's drag that back up. Okay, so we have our start, stop, e-stop, and then run command. And we'll go ahead and we'll download this back in here. So as it downloads, you'll see that this routine will not run. You won't see the bits come on or anything because we don't have it jumping to the subroutine. So first off, we'll add another roam. We'll come in and we'll put a JSR, and we'll simply just jump to subroutine for the function block AOI. Okay, so now that we have the function block AOI, we want to cut on the e-stop. So the e-stop is pressed, or not pressed, it's active. We want to come in, and at this point we can basically we can like toggle the same bit, this conveyor 3 start. So if we cut on the conveyor to restart, then you should see the output cut on. So if we did the stop, then you would see the stop cut on, right? So you see the run command right here dropped, right? So if we looked at the run command on the logic is currently working, and you do it the same way you would on the other logic. So right now that knows the stop button's pressed, it's not okay to run, and the start button's pressed. Now, if we go back to our controller tags and we actually take the stop button off, in 2 seconds it will start back up because we have our start button pressed. Now let's say, for instance, we didn't have our start button pressed. Okay, so now the scenario should be that the stop button has not been pressed and the e-stop is not pressed. So what should happen is we should be timed out with ready to run after 2 seconds. We should be waiting on a start button. And if we hit the start button, then it comes on. So you see that we can use these in multiple instances. We can use these in ladder logic. We can use these in function block. It really depends on how you want to use it. You know, I prefer both. I think it's really versatile either way. It really depends on what you're programming, how you're programming it. But I just want to show a simple scenario of a add-on instruction that we made in the prior video. It in use, and how easy it is to make this a modular system. So make this as a quick and easy way to program something on or off. And what I would kind of like to highlight, if you're making an add-on instruction though, just make sure that you try not to make it too big, so you don't want to really be scrolling up and down trying to figure out stuff, because it makes the person that's trying to use it or trying to troubleshoot it, or for that matter maybe coming behind you, it makes them their job that much harder if they have to scroll down and look at why something's not running. And this should be truly tested logic, that it doesn't have to be edited, because you can't just go in here and edit this without causing a problem. And you have to be offline, and so you would have to take the processor offline just to edit it. Now as far as that goes, I believe we can go in here and might be able to go in the parameters and change the times or something like that, but I don't even think you can do that. So in this instance, what we can do, we probably do it in this one. We could change the time in here, but for the default value, you can't change. For the default instruction, the definition, you can't change the time. So if you want, every time you used it, if you somehow you wanted to change this to 5 milliseconds or 5 seconds to start, then basically you would do that. So let's just hit the stop button real quick. So you can't even toggle it. So let's go back and hit the stop button, and it's going to wait 5 seconds to start now. But just to show you that you can do that individually, so if you wanted to cascade a bunch of conveyors differently, I should say, like if you wanted to have one kind of stagger on before the other one, or you can go in there and do that. But just keep in mind that your default logic, your definition that you first put in, is going to be what comes in first. So if you wanted to do one at 5 seconds and the next one at 2 seconds and the next one, or say you wanted this one at 7 seconds, you could do that. And this one you wanted as quick as possible. I don't know. It depends on how you wanted to put it. But I guess what I'm trying to highlight is the versatility in making your own add-on instructions, or AOIs. It's very no matter what software you're using, or what version of RSLogix or RS Studio is what they're calling, the new name for it. When you're getting up into higher versions besides 21 or 20, then you're still going to use the same process of making a add-on instruction. It does get a little bit different as far as when you get into program tags and stuff like that. So if you get up in the 27s and 28s, version 30, you'll see that the programs have program tags and parameters. So it'll be parameter tags and local tags. And you can share those amongst each other, but that's a whole different topic. And please don't get that confused with the add-on instruction itself, because the add-on instruction itself is still completely separate. So this was just an illustration to show you a lower version, which is version 20, right? And to show you how to make an add-on instruction or use an add-on instruction in the natural ladder logic routine, and then also how to use it under a function block. So again, this is based upon the prior video we made, and if you'd like to see that, it'll be in the show notes below. And again, if you have any kind of questions or would like to see something else, or like to see something that you think might be a little bit more helpful to grow on this, just please leave me a comment below, and yeah, we'll get to it, and as soon as I can, and I'll try to see what I can do to work something out. But again, I appreciate your time. I know this ran a little bit long. It's 21 minutes right now, but I appreciate your time, and please let me know if you need anything else. All right, thank you.